Assalamualaikum warahmatullahi wabarakatuh. Hello everyone, let me introduce myself. My name is Tiara Finglia with name 220291110. I'm from Mathematics Education Program. In this section, I will explain about the pigeonhole principle. Appetizer problem. The subset S of the set A is 3, 11, 19, 27 until 147, 155 is said to be 158 free. If there are no two elements which add up to 158, what is the maximum size of a subset that is 158 free? The pigeonhole principle. Premise 1. If n objects are placed in fewer than n pigeonholes, say n-1, then at least 2 are together in the same pigeonhole. A more general form of this principle states that premise 2. If mk plus 1 objects are distributed at random into n pigeonholes, then some pigeonhole has at least k plus 1 objects. P1 and P2 are informal versions of principle which in formal mathematics are stated more abstractly. Premise 3. If a set of n elements is a union of n less than n of its subsets, then at least one of those subsets has more than one element. Premise 4. If a set of nk plus 1 elements is a union of n of its subsets, then at least one of those subsets has at least k plus 1 elements. The challenge in using this principle as a problem solving is choose the objects and the pigeonholes correctly. Example: in a group of 13 people, one can find at least 2 born in the same month. In this statement, take the people as objects and the 12 months as pigeonholes. Since there are more objects than pigeonholes, the PHP tells us that there are at least 2 in the same pigeonhole. It has at least 2 people share the same month. Example problem 1. 25 points are marked inside the area bounded by a rectangle 6 cm long and 4 cm wide. Show that there are at least 2 points that are at most square root of 2 cm apart. Solution: mark out 1 times 1 cm square in the area of the rectangle as shown below. There will be 24 of these pigeonholes, and we take the points to be the objects. The PHP says that there will be at least 2 points named within or along the boundaries of the same 1 times 1 square. This can be spread by at most the length of a diagonal. Square root of 1 square root plus 1 square root is equals to square root of 2. While cleaning out of the garage, John found 4 or single-digit house numbers 1, 3, 1, 4, and 2, 5. The number of different 2-digit house numbers he can read is solution. All the 2-digit numbers will have distinct digits selected from 3, 4, 5, except the extra possibility 55. Considering this with distinct digits, there are 3 ways of choosing the first letter. Then, having chosen it, there are 2 ways of choosing the second letter. Hence, there are 3 factorial plus 1 number is equal to 6. So, you can create 6 number of different 2-digit house numbers. They are 34, 35, 43, 45, 53, 54, and 55. Solution of appetizer problem. Observe that we have paired them strategically. 158 free. But by the PHP, if we extract 10 plus 1 is equal to 11 elements of A, we are bound to have